I'm here with Dr. Shuji Nakamura, and Dr. Nakamura has received numerous awards for his work, including the Technology and Engineering Emmy Award. You're an Emmy Award winner.
Yes.
That's great. And that was awarded by the National Academy of Television Arts and Sciences. He is the 2014 Nobel laureate in physics, just gets better and better, for the invention of the efficient blue light emitting diodes that have enabled the bright energy-saving white light sources that we have today. Dr. Nakamura is a fellow of the National Academy of Engineering, the National Academy of Inventors, and the National Inventors Hall of Fame. And he has been a professor also of materials and electrical and computer engineering at the University of California, Santa Barbara. Dr. Nakamura holds more than 200 U.S. patents and over 175 Japanese patents. He's published over 550 papers in his field. And Professor Nakamura is the research director of the was the research director, of the Solid State Lighting and Energy Electronics Center. He co-founded Sora Incorporated in 2008, which operates vertically integrated fabrication facilities in California's Silicon Valley and in Santa Barbara. Without his invention of violet laser diodes, the Blu-ray DVD would not be with us today also. And there's a lot of consequential benefits that have come from the technology that you brought us.
Thank you.
Well, you're entirely welcome. Yeah. But you didn't start in lighting. So what's your oldest memory of lighting?
Oldest memory of lighting? I think when I joined the Nichia chemical industry, and I started working for the gallium phosphide bulk crystal. At the time, I read the papers and I found the blue LED and the green LED light is the biggest issue. That is just my old memory of the LED lighting. Yeah.
But when you were at Nichia, they were advising you not to go in the direction that you went, right?
Yes, you're right. Yeah, that happened, I think, in 1991. So I started the blue LED research in 89, and still in 91, there are no great results, and just a very dim blue LED. I could demonstrate very dim blue LED, not bright enough. So company, top of the company say, this is a waste of time, waste of money. So please stop this blue LED research immediately.
And those would have been your bosses at the time telling you that?
No, through my boss, but the top, the president, new president.
Okay.
Yeah, he said so, but I ignored it, just trust.
I'm glad you did.
Yeah, because at that time, I started the blue LED research disparate almost. So at that time, I ignored all kind of companies order or meeting, phone call. I ignored everything. Just I concentrated the blue LED research. So
that certainly worked out in your favor, being contrarian about that.
Yeah.
So working on the LEDs, were you thinking of lighting as the application? I mean, you were thinking of light, obviously, but there's indicator lights, there's flashlights. I mean, was it architectural lighting that you were thinking?
No, at that time I'm thinking on the displays, because in order to make LED display, we need 3 primary colors. So that's the main purpose, is to develop blue and green LEDs.
Okay.
So that's the initial idea, my initial idea to start a blue LED research.
Oh, so it was displays.
Yes.
That's really interesting.
Because at that time in Japan, like Shinkansen, high speed train.
Yeah, sure.
The displays, only they use the orange color. That is, so it's color dirty. So by inventing blue and green, it become full display.
And that brought you into the architectural lighting community as well.
Yeah.
Once they got bright enough.
Yes. So.
But that took some time.
Yes, that time. But when we developed blue LEDs in '93, and initial application for cell phone backlight. At that
cell
time,
phones.
Yeah,
okay.
At that time, cell phone company is developing cell phone.
Yeah.
But there are no backlight. using LCD display because available lighting source is conventional fluorescent lamp or incandescent bulb lamp.
Sure.
There are no way cell phone become huge, 100 voltage, So that's coincidentally we developed blue LEDs. So initially they used blue LED, but the color is blue. But they asked us to develop white LED light. So that is we use phosphor to make white. That is looks like real white light, So that is I think exactly 94, 95. So at that time, this is could be used for lighting. So that's the reason we start thinking about the lighting at the time, 95 or maybe 96,
Okay.
Yeah.
And I know from the architectural lighting community, we didn't see the first viable products in the marketplace till about 2005. So about another decade after you got to that point, they got bright enough, long enough life, and easier to produce.
Yes.
So, okay, that kind of puts a timeline in place. When you started looking at and seeing the application for architectural lighting, were there people that gave you advice or helped you along the way to learn about this particular application?
I think lighting design. I know. I attended the lighting conference, and I did a panel discussion. I think in 2000, around 2000.
Okay.
And I had the panel discussion with lighting design, Japanese lighting. Tomoko Ishii is a very famous lighting designer in Japan. Tomoko Ishii, and she said, white LED lighting, white LED is a commercial available, but she said, I cannot do these white LEDs. Each lamp has different color.
Yeah.
So, okay, she make a 100 lamp, each color different. So, this is bad, because I found that the reason, because blue light direct come blue LED chip. So each blue LED chip has a different wavelength, different color. It's impossible to make the same blue light. So that's the reason. So, that's bad. So when we started Sora, we selected the violet LED to excite blue, green, red phosphor. So in that case, I expected that Tomoko Ishii's claim is I can solve that problem using violet LED. Because the violet LED is still fluctuating color. But all of blue, green, red color phosphor, even the violet light fluctuate, looks all white color same. So, that is good. So that's the reason, another reason we started Sora using violet LED.
That is interesting because initially that was a problem for all of us with LEDs was the binning inconsistencies, the wide variation of correlated color temperatures. So the violet LED helped you with that.
Yes.
Okay.
And then we gave them Tomoko our Sora's product. She said, this is perfect. She said,
well, you pleased her then.
Yes.
That's a good thing.
Yeah.
Was there help from any of the lighting societies? You went to a conference, you mentioned.
Yes.
And that would be the Illuminating Engineering Society of Japan's conference?
Yes, Japan. Yeah, that's
Japan.
I think.
And they're a partner of the IES.
Oh, I see.
In fact,
okay.
we just had them here at our conference.
Yes.
So wonderful. It's actually a big group in Japan. There's 6,000 members of that group, Illuminating Engineering Society of Japan.
Oh, I see.
Yeah.
Yeah, I'm a member of the Japanese.
Good.
Yes.
Did you imagine, or at what point, early on, I wouldn't think you would, but at what point did you start to see that the LED might be able to take the place of the incandescent lamp and the fluorescent lamps? When did that strike you that this really could be the ubiquitous light source of the future?
Well, it's a bit difficult. So, I left Nichia in 2000.
2000, okay.
Yeah, 2000. I think at that time still not so great, but every year, efficiency of LED increases like this,
Right.
Yeah, I think so. I think around 2002 or 3, efficiency is very high, so we expected that to be used for the architectural lighting, Yeah.
In 2000?
I think 2002 or 3, something like that.
That makes sense.
Yeah.
There was a CIE conference
Yeah.
in 2003 that was focused almost entirely on LED. And the products weren't as bright as they needed to be yet, but everybody thought it was coming. And that was 2003, so that's okay, so that's a good fit. And you were once again...
Yeah, also at that time I went to lighting fair. Lighting fair is in Japan, also United States, both.
Yeah, both.
Yeah, and all lighting fair and gradually LED lighting is everywhere gradually. Yeah.
Right now, it's the only source that anybody's investing in. Can you describe to a non-technical person the science behind the breakthrough that you had that you received the Nobel Prize for?
Breakthrough is I think for blue LEDs we use indium gallium nitride.
Okay.
So but the indium gallium material itself, we couldn't grow indium gallium materials since 1960s. Several scientists tried to grow indium gallium nitride, but nobody could grow it, make it. But the big breakthrough is I invented a new MOCVD. It's called two-flow MOCVD.
Yes.
Using this two-flow MOCVD in 1992, we could demonstrate the first growth of indium gallium nitride. That emitted blue, green, all kind of colors. So that's the biggest breakthrough.
Yeah, because prior to that, they were telling you that you weren't going to be able to do it.
You're right. Nobody, Yes. When in 80s, 70s, all scientists almost gave up, developing a blue LED. So.
There's a lesson to be learned there. Don't necessarily listen to the common wisdom, right?
Yes, because there's for example, there's a paper. Famous scientists published a paper at the AP Applied Physics Letter. If the wavelength is shorter, there are no way to develop the LEDs. Some kind of theory. It's totally wrong. So blue is almost impossible. That paper said because the wavelength is too short.
Yeah. So you did the impossible.
Yeah.
Good.
Yeah.
It must be rewarding for you to see, here even where you're being filmed, the lights are LED.
Yeah.
Everywhere you go, the shows certainly, but also in the stores, it's all turning to LED now. If it isn't there now, it will be very, very shortly. That's got to be a very rewarding feeling for you.
Yes, I'm happy to watching all kind of LED display, lighting, everything. So I'm happy. But also same time I told you so. Lighting designer always complained about the white LED. Since '96, color is totally different, something, But I could solve that problem by starting a Sora company, Sora, using violet LED. So.
Sure.
So happy. Also some complaint. So still some kind of complaint. The lifetime of the lifetime of LED is more than 30 or 40 years. But real lighting system lifetime is a couple of years. So, that is driver. It mainly cause a problem, no? But
right.
But they say blue LED is a lifetime short. So still driver is a problem, no? Right? Driver lifetime is like a capacitance and the transistor lifetime is not enough,
Right.
Because the LED itself is lifetime very long, but driver lifetime is not enough, no.
And the technology you develop potentially could last much, much longer and outlast the drivers.
Yes.
But what we've seen in the marketplace of late is with prices dropping, so has quality. And we've seen some of these LEDs being rated at 2,000 hours.
Yeah.
But it's not the LED that's the problem.
Yes.
It's the rest of the electronics, right?
Yes, you're right. Yes.
Because you haven't invented the driver.
No, I never asked the driver, so I have no knowledge of that.
Right. Yeah. Well, we can't find fault with you there.
Yeah.
I want to share with you something that I learned recently about the savings for energy in the United States based on LED conversions.
Mm-hmm.
And our Department of Energy did an analysis in 2016 that showed a savings of $2.8 billion in 2016, 1 year. A savings of $2.8 billion due to the energy savings from LEDs. And of course, their solid state lighting program accelerating their penetration into the marketplace. That's just 1 year's worth of savings.
Wow, it's great.
It is great.
Yeah.
And if all we had were, the early LEDs or really the indicator lights and the colors and not the white LED, we wouldn't have that.
Mm-hmm.
So that's something else that should help you sleep at night.
Oh yeah, it's great. Yeah, it's great. Yes.
It is crazy.
I never thought about it. So
Yeah, and that's a gift that keeps on giving, because year after year those savings continue to accrue until the whole market has transformed.
yes, you're right. Still, LED penetration is not 100%.
No.
30? I don't know. 30%? I have no idea.
Yeah, it's a little higher for exterior than it is for interior, but we aren't even halfway there on either one yet.
Oh, I see.
So there's a lot yet to be done, but the momentum is there
Yeah, great.
right now.
Yes.
So there's so much more to look forward to. Was it difficult for you to get financial backing for moving forward with the indium gallium nitride when everybody was telling you and these scientific papers were telling you it can't be done?
Yes, you're right. Yes. But at the company, chairman always helped me a lot.
The chairman helped
Yeah,
you?
top guy, founder of the company.
Yeah.
And but other manager people didn't like me at all. For past
They
10
didn't-
years,
they didn't
past
like
10
you.
years, no results. So they always ask me to quit the company. But the chairman, helped me. So nobody complained. He's a founder, top guy, no.
Okay.
So, and he gave me a good thing is he gave me the freedom of research. He never interfered in my research, and so I can do anything. And but budget is very small, funding, because small company. So, but I can do anything. So I could make all kind of decision myself. So I in '92 I think indium gallium nitride is most important. That's the emitting layer, emitter. So I tried to using grow indium gallium nitride using two-flow emissivity. So I spent a couple of months and I got a great, fast indium gallium nitride layer. So that is a big breakthrough. So it's okay.
It worked out.
Yeah.
And now those people who didn't like you, you can just show them your Nobel Prize.
Yeah, but I definitely just, I don't know what they're thinking,
What was the breakthrough moment for you when you knew that what you're working on with gallium nitride was going to be successful? Was there a pivotal moment where you just said, oh, I can do this. It's going to work?
Oh, so to make a real high efficient LEDs, I needed several breakthroughs.
Yeah.
It's like it's climbing a Mount Fuji. So first breakthrough is two-flow emissivity, and the next is buffer layer. Next is P-type gallium nitride. Next is indium gallium nitride. In the final device. So gradually like this.
One step at a time.
Yes.
Okay.
Yeah. So.
Is there a current project that you're working on?
Yes. Right now at the UCSB, we were focusing on laser lighting, laser diode. So laser lighting, they have a huge, big potential as a next generation lighting.
I'm going to want to spend some time on that. I looked at your Nobel presentation that's online, and one of the quotes on your slide says, LED-based white light is great, laser-based is even better.
Yes.
Why?
Oh, because using the same size of chip, input power for the laser diode is 100 times higher than the blue LED. So it is using same size, 100 times brighter using
Okay.
a laser diode.
Well, you said input power is
Yes.
100 times higher.
Yeah. Blue LED, we increase the input power 100 times,
Yep.
no emission.
Okay.
LED. That is, it's called the droop.
Oh, sure, the droop factor.
Yeah, yeah. But the laser diode, input power 100 times higher, still very efficiency very high.
So it's more linear, the input power with the output.
Yes.
emission.
Yeah, almost, yeah.
Okay. Well, but we're not seeing laser being used in general illumination.
Yes, and there are several reasons. One is laser diode, its cost is very high.
Okay.
I think, I don't know, 10 times or 20 times higher than the LED. That is one reason. Also, light out power of the laser diode is 100 times higher than the LED. So available phosphor is limited. So right now, color of white is not so beautiful. So outside lighting is okay, but for general lighting, we need more good phosphors to improve the color of the white. So that's the second reason.
So we have to work on the color, and then the price will probably drop,
Yes.
right?
Yes,
With
so-
economies of scale.
Yes. Price. Also, laser diode, the processing is very complicated processing technology. So,
Okay.
and that's the reason. So no, laser diode, infrared laser diode are available, but infrared laser diode is still very expensive. That's a conventional laser diode. So we need two breakthrough. One is we have to reduce the cost. Another breakthrough is we have to develop new phosphors to improve the white color.
I'm going to guess here that you're working on that.
Yes, you're right. Yes.
Okay.
Yes.
So we may see that from Sora.
Yeah, Sora laser diode. Yeah,
Sora laser diode, right?
Yes.
Okay. But your laser products that you're making now, they are in the marketplace. Are they automotive application?
Yes, it's still some pressure, but it's coming. So next year, it's coming for mass production. It's coming. So from next year, you can see the real product of the headlamp.
Are you able to tell us more about that?
I think BMW,
Oh, BMW, okay,
Yeah,
good.
Laser headlamp from next year. Yeah.
Oh, that'd be great. In the United States?
I think so. Yeah.
Good.
Yeah.
Good. Will it be one of those tracking lights?
Oh yes, tracking light also. Basically, laser lighting is a very small point light source.
Yes.
We can put MEMS. After MEMS, it becomes a laser projector. So we can make any image. It's called dynamic lighting.
Okay.
And so laser projector, headlamp becomes laser projector. So image sensor, take some kind of image from the car is coming. So this region, laser projector becomes darkened. Any image, it's okay. So yeah, combination of the image sensor, we can do anything for this is dynamic lighting. So
That'll be a real improvement, won't it?
yes.
Yeah. And then, of course, being used in automotive, as we've seen with other technologies in the past, that brings more product into the marketplace and lowers the costs and makes it more available for other uses.
Yeah. LEDs are, the chip size big, so they can remember. But they use a LED array, and they make some kind of image, but still image is not so good.
Not yet. no.
Yeah, not bright enough. No.
It'll get there.
Yeah.
What do you see as the next big technologies? I mean, obviously laser has a ways to go yet. Is there anything else you're looking at for lighting that you think could be a new technology on the horizon? Or are we going to be living with LEDs and lasers for the foreseeable future?
I think LED and lasers future for lighting. Yeah.
I remember, in fact, I met you at a conference, a DOE conference years ago, and we talked a little about this, but I had read a statement from you saying that OLEDs were already surpassed by LEDs, and they were never going to be the dominant light source. they couldn't do it.
No, OLED is always a reliability problem. OLED is organic materials,
Right.
So you can understand, so reliability is not so good. All relative problems. Even for the display, still they have a problem with reliability. For lighting, even lighting is a heat sink. How to remove the heat is most important.
Right.
OLED is, we can't increase the input power for using OLED. Always like very dim lighting is okay. Mood lighting is okay because power density is small. So in that
Tail
case,
lights.
Yeah.
On a car.
I think for lighting, no way for it. I think.
Okay.
Yeah.
Well, that's okay. That's a pretty clear opinion. You taught for quite a while. What was it about teaching that you enjoyed? What drew you to that?
Oh, teaching is because students, Students are very young, so I think students, I said young, so always abnormal, crazy, always coming from a student. So I'm very enjoying working together with the students because I know all the people have a lot of knowledge, but the thinking is not abnormal, always
Sure.
too old. But young people are always crazy. Wow, what this is sometimes bad, but sometimes great, So I think I'm very important. Young student work together. Young student has crazy ideas. That's great for me. So
Yeah, they're not. They're more open-minded.
Yeah, open mind and still brain is very active,
Sure.
The thinking is very deep, sometimes very deep, it's very broad. So it's amazing. So. Yeah.
Well, that's interesting because what you're saying is, despite your achievements, they stimulated you.
Yes, you're right. Yes, you're right. And also, same time they have to graduate. In 5 years. So we have to work very closely, to make a big invention, something, very big discovery. So working together with students, always I can get a big invention and discover still. Without the student, I can't do it.
Well, that's fascinating. Were there any particular things students were working on that got you excited?
Yeah, especially we are working for the LED lighting, laser lighting. It's always, you can see the UCS papers. Always great. We have a great paper among all kinds of galvanic research. I think our UCS is always top ranking. Yeah, because this is a student is always, UCSB, especially material department is already top ranking in the United States. All great students coming. So.
Yeah, and they post a lot of that on the U of C website.
Yes, you can see it. And, so that is always all kind of results are contributed by students, smart students and crazy students.
But you're not teaching now.
No, not teaching.
Okay.
Yeah, and maybe in the research professor. Yeah.
How about the future of Sora? I mean, we know you're working on lasers.
Yes.
Any other technologies that you're?
I think the future of Sora is basically using Sora is a violet LED to make white. So spectrum of the white is a full spectrum, almost same as the sunlight. I think this is the most healthy lamp. I think now people understand that health is most important. So right now we are focusing on how to save energy using LED lighting, but now people start thinking about health.
Yes.
Yeah, I think Sora's lamp is very good fit for as a future lighting for concern of health. Yeah.
We talk circadian lighting, those kind of things.
Yes.
You think you've got some applications there that you can move forward
Yes.
with?
Also, recently in Japan, I published a paper, and that paper is now public. And for myopia, all of children have myopia.
Myopia, sure.
Yeah, but that myopia is caused by the lack of violet light. Because all of children stay at home to study very hard or enjoy game, but this lighting is totally different from sunlight. So that I doctor say, at least every day children play outside, at least every day 2 or 3 hours, every day under sunlight, basically no myopia.
Oh, I did not realize
inside the room,
Yeah.
All of window has a filter to cut the UV. Same time violet too. From violet they cut. So no violet light inside the room. And the lighting doesn't emit violet. But the solar is violet. So, you can understand how sunlight is very important for human health. So I think, so now people think about the health, healthy life.
Sure.
Yeah.
That's really fascinating. I didn't realize the connection between the violet and the myopia. That's an established connection. I mean, that's
Yeah, that is one example. Also, blue light problem, circadian problem.
Okay.
Yeah, and I think so. Basically, sunlight is the most healthy lamp. So we have limited sunlight. So in that case, using blue, nobody can make sunlight. No, only violet. No, violet LED. So I think. So direction of the healthy lamp, in that case, solar is a right direction. So yeah.
That's a tricky area right now because there's a lot of research yet to be done, and there's so many variables with human physiology with circadian light. So if you make a lamp that's a healthier lamp, there's going to have to be some research done, right? And it probably isn't something that Sora would do. Who would do that research?
I think who is the judge? I don't know, the CTO, CTO changing. But best lighting is you can sunlight, no?
Right.
We have to imitate sunlight, morning light, daytime lighting, and nighttime lighting. So nighttime lighting is black is best, no light. But nowadays people work on nighttime, so nighttime lighting, no blue is best. So
yeah,
in that case we have to make white using violet or something. So daytime is blue light is very important. Morning light, blue is very important. Daytime also blue light is very, very important for full spectrum. So,
right.
So depending on the timing, we have changed from morning to the nighttime, gradually.
But I guess what I'm saying is that we don't have clear recommendations for the intensity, duration,
Yes.
and spectral characteristics yet.
Yes, you're right.
But we have a lot of companies that are starting to move in this area.
Yes.
So we're going to need to define this better.
Oh yes, you're right.
Who's going to do that?
Great question. DOE?
DOE? Good. That's the
Jim
answer I
Broderick?
wanted to hear.
Jim Broderick, yeah.
Or Brian Walker now.
Oh,
I
Brian
guess.
Walker, okay.
Yep. Okay.
Yeah.
Good.
Yeah.
I'm curious about something. How would you describe Sora? Is it an electronics company? Is it a technology company? If you were to categorize Sora, what are they?
I think that they're maybe the fixture company.
A fixture company.
Yeah.
Okay.
Yeah.
Because a lot of the lighting companies call themselves electronics companies now because they made the transition to solid state lighting from the old vacuum tubes, right? Okay, but you're a fixture. So as a fixture company, obviously you participate in the you're here at an IES conference where we're recording this, which is wonderful, and you come to shows. I've seen your presentations and booths at Light Fair. Do you do anything at the Consumer Electronics Show?
Sora?
Yeah.
Ooh, I don't know. This year probably they didn't. I don't know this.
Don't know? Okay.
No.
I just was curious because I'm noticing that there's a lot of circadian lighting now at the Consumer Electronics Show.
Oh, okay.
And it's coming outside of the normal channels. Companies like the Casper mattress company makes a circadian light, and it's coming from unusual places. I just wondered if you were participating in that in any way.
Oh, no, I don't know. This.
Okay.
Next time this year, last year, I don't know. Yeah.
Maybe I just planted a seed there for you.
Yeah, last time CS only, so I think Sora laser diodes at the booth.
Okay.
Sora, I don't know. Yeah.
I'm a little stymied here because you're the amount of effect that you've had on the lighting industry, and I've been a part of this industry for a long time. It can't even be stated. I mean, it is absolutely remarkable. and speaking on behalf of this community, and certainly on the energy efficiency community. And as we move into light and health and the LEDs and lasers point in that direction, I'd just like to say thank you
Okay,
on
thank you.
behalf of this amazing industry. And thank you for joining us for this interview today.
Okay, thank you.
Thank
Thanks so
you.
much.